the next thing we need to learn about is something called logical shifts. Now, we've learned how to add. What we've not learned how to do is multiply. Let's say we've got a simple kind of sum here. I want to say 4 times by 12. Okay? Now, believe it or not, processors, they don't really multiply. What they do is they just add numbers to themselves. If I did a loop, I could get 12 to add to itself once, twice, 3 times, 4 times, and it would give me the answers. So I could crank it once, gives me 12, add it to itself again, 24, add it to itself to again, 36, add itself to again, 48, and you can see I've just done this once, twice, 3 times, 4 times. This one gives me that, gives me the number of times I need to crank it, and that one does it like that. Okay, and that kind of works. Okay, but what about this? What happens if I wanted to do 48 times by 64, right? Now, how many times am I going to have to turn it around? You're telling me that we'd have to write a loop that starts with 48 and then adds it to itself once, twice, 3 times, 4 times, skip a few, 63, 64. That's a lot. What happens if you want to times by 1,000,000? That is really difficult. It's going to take a lot of processor cycles, a lot of fetching, decoding, and executing. It's going to really slow your computer down. We need a better way. Now, the better way is this. There's a concept of something called shifts. So I'm going to write in a nibble here, 0, 1, 1, 0. That's a nibble. I'm just going to title it 1, 2, 4, 8. And I'm going to do what's called a logical left shift. And let's say it's by 1. Okay, what's that going to do? Here's what it's going to do. It's literally going to move each of these numbers up by 1. So the 0 goes up here, this 1 goes up here, this 1 goes up here. I'll rewrite it underneath, and hopefully it'll be clear to see. So now we're saying that this 0 is here. In fact, I'll stick with there you go. This 0 is here, this one's here, and this one's here. So you can see that that went here, that went here, that went here. This 0 fell off the side of the earth. It's what's called an overflow error, as you met from before. And then we pad in this space here with a 0. Now, what was the point of that? Well, let's explore this. Let's see what the actual numbers are. This number, the top one, is 4 and 2, so that's the number 6. The number underneath it is 8 plus 4, it's 12. Now, can we see what the relationship is between these two numbers? Right? They're doubled. If you shift again, you times it by 4. If you shift them up again, so shift it 3 times, you times it by 8. You shift it 4 times, it times it by 4. Here's the deal. Basically, logical left shifts are 2 to the power of the shift. I shift it 5 times to the right, it's 2 to the power 5, which is, I believe, 32. If I shift it 6 times, it's 2 to the power 6. So I'm shifting all the numbers up by 6. Now, you might have an overflow error, but let's ignore that for the moment. You shift it 6 times to the left, you've times it by 64. And if you remember, that was the problem we were talking about. So instead of adding it to itself 64 times, you simply shift it up 6 times. Much more efficient, save you a lot of time. So that's what logical left shifts does. Every time you shift once to the left, you times it by 2 again. Shift it by once, times it by 2. Shift it 2, times it by 4. Shift it 3 times, times it by 8. Shift it 4 times, times it by 6, etc. Not talked about right shifts. So right shifts, in fact, let's just clear this a little bit, shall we? So right shifts are the same concept, except now we're going to go in the opposite direction. So we're going to go a logical right shift. Let's plug some numbers in here. So 1, 1, 0, 0. I'm going to do a logical right shift by 1. Okay, so I'm now going to move everything up by 1 to the right this time. So this 1 becomes a 1 here, this 1 becomes a 1 here, this 0 becomes this over here. So that goes this way, that goes this way, that goes this way. This 0 falls off. This is no longer an overflow error. This is called a underflow error. And then what you pad with, this space that's freed up, again, you pad with a 0. Okay, let's explore what the numbers are. 8 plus 4 is 12. Underneath it, it's 4 plus 2 is 6. What's the relationship between the two of them? Between 12 to 6? It's half, or you divide it by 2. And that's a relationship. If you shift once by right by once, you times it by, you divide it by 2. If you do it twice, you divide it by 4. If you shift it 3 times to the right, you divide it by 8, etc. Essentially, what you're doing is, again, you're doing 2 to the power, but where before it's 2 to the power 6, now if we go on here, if we shift it 3 times to the right, it's 2 to the negative 3 if you shift it 2 times to the right. And that's actually 1 over 2 to the power 3, which is an eighth, or dividing it by 8. Let's work through some examples.